This is whenever we first get to circle Mercury. Out there at the front of our planetary group lies Mercury, a little uninhabited planet enclosed by a snare of interest and secret. At a simple look, nothing appears to be influential about this planet. However, ongoing examinations by NASA have uncovered some surprising disclosures about Mercury that no one anticipated. A portion of the stunning revelations, including information from the James Webb Telescope, have ignited controversy within the scientific community, with many referring to the possibility of extraterrestrial species hiding on the planet. Amidst the tumultuous discoveries and unusual conspiracy theories, a new plan is emerging within the academic community. The grand plan to strip Mercury of its incredible veils and uncover its dark secrets once and for all. What amazing mysteries have scientists found about Mercury? And what revolutionary plans does the academic community have for this strange cosmic neighbor? Join us in this video as the Webb Telescope finally reveals what NASA was concealing on Mercury all along. Our planetary group is more than simply an inherent assemblage of planets swinging in an enormous skirmish. Around each of the 8 planets that make up this baffling ring system, there are unique features of their own. Despite planets like Jupiter and Mars taking the spotlight with their great importance, another fascinating planetary body that seems lost in the group is Mercury. Mercury is the planet that lies at the very first spot on the list of planets arranged by proximity to the Sun. Its distance from the Sun is a mere 58 million kilometers compared to Earth's 150 million kilometers. Mercury is also quite small compared to Earth, measuring just 3,000 kilometers in width. Due to its small sweep around the Sun, Mercury is the fastest planet to complete its revolution around the Sun at an incredible speed of 47 kilometers per second. The planet completes a full rotation in just 59 days. In total, 1 year on Mercury is simply 88 days or 3 months on Earth. Mercury's small size and massive speed are just a few of its unique features. From a distance on the vast map, it even looks like a livable planet. The little planet has forever been captivating to mainstream researchers. Yet for some reason, it hasn't garnered the same attention as most of its cosmic neighbors. The first recorded observation of Mercury was in 265 BC. Early stargazers like Zupus in 1639 also studied the planet. However, all the academic community had in these early times were fragments and bits of information, as their research was conducted using inadequate scientific equipment and ancient telescopes. It wasn't until the 1960s that truly substantial information about Mercury came to light, thanks to the efforts of the National Aeronautics and Space Administration, NASA. A few years ago, NASA revealed the first genuine images of Mercury to the public. These larger-than-life photos showed Mercury as a divine epitome of beauty and complexity. However, this didn't come easily. In reality, despite years of planning and purposeful work to explore Mercury, researchers were only able to observe it from a distance. Scientists have a tough time keeping an eye on Mercury as they do on other planets due to its proximity to the Sun. The Sun's harsh rays and bright light can damage optical instruments like telescopes when they focus on Mercury for too long. As such, researchers can only observe the little planet for a few minutes at a time to prevent damage to their equipment. Even the James Webb Telescope cannot point towards the planet due to its closeness to the Sun. It's quite perplexing how this relatively small nearby planet is harder to study than the more distant planets. All due to the temperature and gravitational pull from the Sun. Sending a probe to Mercury is more like a suicide mission than a heavenly mission. The probe must adjust to the temperature, environment, and gravitational forces there. Otherwise, it will fail. It would surprise you to learn that Mercury zips around the Sun at an incredible speed of 30 meters per second. This time-breaking speed makes it the fastest orbiting planet in our solar system, which also poses a challenge for spacecraft that plan to study the planet or land on its surface. So far, only 2 space missions have had Mercury as their target. Mariner 10, launched on November 3, 1973, and Messenger, launched on August 3, 2004, are the only spacecraft to visit Mercury. Both of these missions were the brainchild of NASA and are the primary sources of nearly all the information we have about Mercury today. For one, the Mariner 10 spacecraft conducted 3 flybys, each revealing the crater-ridden surface of Mercury and also shedding light on its magnetic field. If you're wondering, this spacecraft was equipped with 2 telescopes, a magnetometer, and a plasma analyzer. NASA planned to gather as much data as possible from Mariner 10's visit to Mercury. As it happens, the probe gradually made its way to the little, fast planet. As Mariner 10 approached Mercury, researchers were astonished to see the planet's chaotic surface. It was riddled with craters and ridges, much like our moon. The images from Mariner 10 were stunning, as Mercury turned out to be nothing like what experts had ever expected. Besides the rugged planetary surface, the spacecraft also detected a weak magnetic field and an unusually large core. Altogether, Mariner 10 took over 2,700 pictures of Mercury, providing researchers with a unique and unmatched view of the captivating landscape. The second flyby of Mariner 10 was on September 21, 1974, during which it captured the southern polar region of the fascinating planet. The final flyby of Mariner 10 was in March 1975, after which it stopped sending signals to Earth. Later investigations revealed that the spacecraft had depleted its fuel supply and could no longer make any adjustments. The grand work of Mariner 10 was continued 30 years later when NASA's Messenger took off to the nearby planet. Unlike its predecessor, Messenger didn't just conduct a flyby but also managed to orbit the planet. Thanks to this, researchers were able to gather more in-depth and fascinating data about the planet. Armed with the intriguing images of Mercury, NASA sought deeper insights with this mission. This time, it wasn't just about pictures. The agency wanted to learn more about the environmental conditions and chemical composition of the planet. NASA also aimed to study the planet's magnetic field, as well as delve deep into its geologic history and planetary core. As you'd expect, the Messenger probe was equipped with all the necessary tools it would need for this ambitious mission. Interestingly, the probe made 3 orbits around Mercury, during which time it took around 200,000 photographs of the planet. These photos were remarkable as, unlike the Mariner mission, they featured both sides of the planet. During the Messenger mission, the probe successfully entered the planet's orbit, hovering at around 25,000 kilometers above the planet's surface. This proximity allowed the probe to capture images of both the light and dark sides of Mercury. Later, diving deep into the images and comparing them with data from the probe's instruments, NASA discovered that our dear sister planet had unusually high concentrations of calcium and magnesium on its night side. Moreover, the planet's magnetic field appeared to be oddly distorted, seeming stronger and more intense in the northern regions. This strange pattern of the magnetic field puzzled researchers for years until in-depth studies and analysis were conducted to uncover the secret behind this anomaly. You see, Mercury's abnormal and strange magnetic field is due to how the planet formed. Magnetic fields on planets are generated from the reactions that occur in their core. Take Earth as an example. The innermost parts of Earth's core contain liquid iron, but towards the inner layer, this iron changes to solid. The continuous or gradual solidification of liquid iron in the core causes the magnetic field. As such, more and more solid iron is being formed in our planet's core every year. As liquid iron cools and crystallizes to form solid iron, it interacts with the surrounding liquid iron. As this happens, as the Earth rotates around its axis, a form of convective current is created. Eventually, strong electric currents are generated that produce a massive magnetic field extending into space. This is the exact method of operation for Earth and how its magnetic field lines are produced. For Mercury, however, it's a different ballgame. In fact, Mercury's method of operation is so odd that it left researchers completely astounded. In recent research led by Hoer from the University of California, Los Angeles, it was found that iron transitions from liquid to solid at the core's outer boundary. This is completely different from Earth, where the transformation from liquid to solid occurs at the core's inner boundary. Ho had this to say, "We had figured out how the Earth works, and Mercury is another terrestrial rocky planet with an iron core, so we thought it would work the same way. But it's not working the same way. It's like a blizzard in which the snow forms at the top of the cloud, the middle of the cloud, and the bottom of the cloud. Our analysis of Mercury's magnetic field shows iron is snowing throughout this fluid that is powering Mercury's magnetic field." Further research showed that Ho's study was consistent with data from NASA's Messenger mission. The incredible discovery led researchers to believe that planets have more than one approach to generating magnetic fields. Although the cores of Mercury and Earth contain similar constituents like sulfur and iron, specific differences in these two planets can produce surprising contrasts, as seen in their magnetic fields. However, the uniqueness between Earth and Mercury extends well beyond their magnetic fields. You see, there are many other rules that this celestial body doesn't seem to follow. For instance, scientists were baffled to find that temperatures on the planet could rise to values beyond 800 degrees Fahrenheit 427 degrees Celsius, which is near the melting point of zinc. But during nighttime, temperatures could plummet to minus 330 degrees Fahrenheit minus 201 degrees Celsius. This wild fluctuation in temperatures left researchers baffled for years. Some researchers attribute this fluctuation to the planet's position relative to the Sun. Mercury has an elliptical orbit, meaning its distance from the Sun varies between its closest and farthest points. However, that alone cannot explain the temperature differences on the planet. To learn more about this bizarre phenomenon, researchers had to combine data from the Mariner and Messenger missions. It turns out the wild temperature differences are due to Mercury's atmosphere, or lack thereof. The atmosphere is quite thin, so thin that it's nearly negligible. Because of this, the atmosphere is incapable of capturing or regulating heat on the planet's surface. Consequently, temperatures rise very high in the day when Mercury is closest to the Sun and drastically drop during the night. Another oddity that has baffled experts for years is the chaotic terrain on the planet. This terrain is a wild, bumpy ride of ridges, valleys, and peaks that seem to follow no specific pattern. It's a landscape that's as confusing as it is intriguing. Scientists have dubbed this region the weird terrain, and for good reason. It's like someone took a hammer to the planet's surface, smashing and scattering chunks of it in every direction. But as random as it may seem, the chaotic terrain is no accident. This bizarre landscape is believed to be the result of a massive collision that Mercury had with a comet or asteroid billions of years ago. The impact was so powerful that it sent shockwaves across the planet, deforming the surface and leaving behind this jagged, unpredictable landscape. Another strange feature of Mercury is the hollows. These are depressions scattered across the planet's surface, which appear to be relatively young compared to the surrounding terrain. These mysterious pits are thought to be the result of volatile substances escaping from below the planet's surface. As these materials evaporate into space, they leave behind these hollowed-out depressions. Moreover, one of the most intriguing and unexplained features of Mercury is the Caloris Basin, a giant impact crater that's about 1,550 kilometers in diameter. This basin is so large that it's visible even from Earth with the right equipment. The impact that created the Caloris Basin was so intense that it caused the opposite side of the planet to form what is known as the weird terrain. The Caloris Basin is not just a massive scar on the planet's surface. It also has a unique, almost mesmerizing pattern of ridges and troughs radiating from its center. The cause of this strange formation remains a mystery, with some scientists speculating that it's the result of seismic activity following the impact. Lastly, Mercury has something that is both fascinating and perplexing: water ice. Despite being so close to the Sun, there are permanently shadowed regions within the planet's craters that never see sunlight. These regions, located near Mercury's poles, are so cold that they can trap water molecules, preserving them as ice. The presence of water ice on such a hot planet was initially met with skepticism, but subsequent studies, including those by the Messenger mission, confirmed it. The water ice found in these craters could be ancient, possibly dating back to the early days of the solar system. This discovery has significant implications for our understanding of the delivery and preservation of water in the solar system. Scientists are keen to learn more about this ice and its origins, as it could offer clues about the history of water in our solar system. These intriguing features and mysteries of Mercury make it a planet of interest for future exploration. With advancements in technology, we may one day be able to uncover more of Mercury's secrets and better understand the complex processes that have shaped this enigmatic planet.